A mountain of stone is falling through the night, older than oceans, older than bones, older than memory itself. It does not hurry, yet nothing on Earth can outrun it. Cities sleep, tides breathe, satellites whisper, and above them all the dark carries a verdict written in fire. Somewhere in the silence, humanity opens its eyes. For most of our history, the sky was a ceiling painted with myths, gods, omens, eternal lights. But now we know it is also a shooting gallery, and every so often the target is us. The realization is both terrifying and strangely intimate. The same cosmos that gave us iron in our blood also keeps a ledger of wandering stones, some of them large enough to erase entire chapters of life in a single incandescent moment. Picture the planet from far away, blue, fragile, wrapped in a skin of air thinner than the peel of an apple. Around it, countless fragments of the early solar system drift like forgotten construction debris. Some are pebbles, some are mountains, a few are nightmares. We have seen what happens when one of them arrives uninvited. 66 million years ago, a body perhaps 10 kilometers wide slammed into what is now the Yucatan Peninsula. In the time it takes you to inhale, forests ignited across continents. Oceans rose and then retreated. The sky itself became a furnace. The age of dinosaurs ended not with a roar, but with a rock. And yet here we are, a species that builds telescopes, that maps trajectories, that dares to imagine not only predicting doom, but preventing it. We have grown from frightened observers into reluctant guardians, standing watch at the shoreline of infinity. But what would it truly mean to deflect an asteroid? Not to shatter it in heroic cinema, not to gamble on miracles, but to nudge a cosmic bullet just enough that it misses Earth by the width of a whisper. The answer begins with something deceptively simple: time. Space is vast, and distances are cruel, yet a tiny change made early can grow into salvation. Shift an asteroid by a few centimeters per second years in advance, and the planet will no longer be where the rock expects it to be. Earth will have stepped aside, like a dancer avoiding a clumsy partner. Elegant, almost gentle. But reality, as always, resists poetry. For decades, scientists argued about what these objects are really like. Are they solid monoliths, iron hearts wrapped in stone? Or loose rubble piles, fragile as a sandcastle barely holding together in the tide of gravity? The difference is everything. Push a statue, and it moves. Push a heap of gravel, and it absorbs the blow, rearranging itself while stubbornly continuing forward. Recent experiments, computer simulations, and daring missions have begun to peel away the mystery. When humanity deliberately crashed a spacecraft into the asteroid Dimorphos, we witnessed a truth both hopeful and humbling. The impact did change its orbit. It worked. Yet the way the surface erupted, spraying plumes of debris like a comet suddenly awakened, told us that these bodies can be at once cohesive and chaotic, stronger than expected, yet unpredictable in how they respond. Denser, tougher, less willing to yield. Imagine trying to alter the path of a moving freight train by throwing a suitcase at it. Now imagine that the train is made not of steel, but of boulders the size of houses, bound together by gravity so faint that a firm jump might let you escape forever into the dark. You hit it, and instead of sliding neatly away, it coughs, shivers, and continues, changed, but not obedient. So we refine our dreams. One option is the kinetic impactor. Slam something massive into the asteroid and let momentum do the rest. Brutal, yes, but governed by physics as old as the universe. Another is gravity itself. Park a heavy spacecraft nearby and let the mutual attraction, patient and invisible, tug the intruder onto a safer path. It is the softest rescue imaginable, a cosmic hand guiding rather than striking. There are more exotic ideas. Paint one side so sunlight pushes unevenly, attach engines that burn for months, sighing against eternity. In the most desperate visions, even nuclear devices enter the conversation, not to obliterate, but to shove, to flash heat across the surface and create a recoil, a violent breath in vacuum. Every method whispers the same requirement: knowledge. We must know the asteroid's mass, its spin, its composition, the way it fractures, the way it drinks energy. Get it wrong, and the nudge becomes meaningless. Or worse, it becomes fragmentation, turning one threat into many, a shotgun blast aimed at a world that cannot hide. And here, the drama deepens, because the earlier we act, the smaller the push required. Discover a dangerous object 20 years before impact, and a change in velocity smaller than a strolling human might suffice. Discover it months before, and the necessary force rises to something terrifying, bordering on impossible. The universe rewards foresight. It punishes procrastination. This is why telescopes scan the night tirelessly, why catalogs grow thicker every year, why astronomers lose sleep calculating probabilities that hover like storm clouds over future calendars. Most days the numbers calm us. The sky is busy, but it is mostly indifferent. Most stones miss, but someday one may not. And if that day comes, the story of deflection will not be about heroics alone. It will be about coordination across nations, about trust, about launching hardware with exquisite precision, about engineers whispering to equations while the world watches. It will be about fear transformed into action, about a civilization proving that intelligence is not merely the ability to understand danger, but to step aside from it. Imagine the moment of success. The asteroid passes, still immense, still ancient, but now sliding harmlessly through space where Earth is not. No fire, no winter, just a collective exhale from billions of lungs. Children going to school, waves continuing their endless rehearsals with the shore. History would remember it as the day humanity touched the heavens and the heavens moved. Yet even then, the vigilance would remain, because deflection is not a final victory. It is a promise to keep looking up, to accept that survival in a cosmic neighborhood requires maintenance, humility, and courage, renewed generation after generation. We are, in the end, a young species on a small world, learning the choreography of gravity. The rocks will keep coming. Some will glitter and pass. One might aim true. And somewhere in laboratories and control rooms, people will be ready, armed with mathematics, machines, and a stubborn refusal to become another layer in the fossil record. A mountain of stone is falling through the night. This time, we may teach it to miss.